All right, so we've done sweeps. Let's do the revolve. Now with the revolve, so this is like doing something like a doorknob. Would be a classic case of using the revolve tool set. Now, doing a revolve is a two-step process. So like the sweep, you drew the path and then the profile. The revolve is the same deal. Now again, the view that you start in is important because you've got to set that first working plane to draw the axis of rotation. So first of all, oh, sorry, this thing's not working here. So when you're doing the two steps of drawing revolve, axis of rotation, and then the profile is being revolved. So let me just walk you through it here. So here's the revolve command. So the first step is to draw the axis of rotation. So first of all, we hit the axis line tool. And now I am in plan. So my axis line is being drawn in the horizontal plane. So if we're doing something like a doorknob, if you think about how that shape is built, so this is going to create a donut with a hole that you would see horizontally. So first of all, I draw the axis, and then the boundary line defines the shape that is built or rotated around the axis of rotation. So when I finish, you folks can see in 3D here, it created a couple of donuts there. So if I go back and double click on it again, now I can see the shapes that were swept. Now, if I wanted to do something like a doorknob, what I would have to do, so for one of those non-accessible round globe style doorknobs, I would have to draw just an arc, not a circle. So I draw an arc right on the line. Now, to draw the part of the knob that goes into the door, I just draw a straight line for that. And then I would return back into the axis of rotation and finally come down the axis of rotation to where I had started. Now this is not valid because this form here is self-intersecting. So I need to grab this little curve here and just pull it back. So the rules with your revolve is that the shape must be closed and the shape cannot cross the axis of rotation. So this would not be allowed. So as long as the shape does not cross over the axis of rotation, you can draw it on one side or you can draw it on the other. Doesn't matter which side you draw it on, you just can't allow whatever you draw for boundaries to pass over the axis of rotation. So when I finish, there you go, kind of like a doorknob right there. And I drew it in plan so the rotation line is horizontal. If I'm in elevation and I start my revolve, now my axis of rotation must be in the vertical plane. Now actually that's not true. I could draw this line horizontally like so, and that would be my axis of rotation. But if I wanted something to rotate around horizontally, I wouldn't be able to draw that in plan. I'd have to draw it in elevation and I would have to draw that axis line vertically. So now that would allow this shape to be drawn and then rotated. So you can see the resulting rotated form right there. Now just like with the other tool sets, I can use the set work plane command to indicate the plan that I want to work in, and that would, I could put my axis of rotation in that plane. So if I hit set and I choose, oh, it's not going to allow me to change it now. No, so I have to start that at the beginning. Okay. All right, so that is the revolve. Let's go on to blend. So the blend is kind of like, I'm not exactly sure what tool I could relate it to in another piece of software. It's an extrusion where the beginning and end are different shapes. So folks, if you look on the Create tab and you see the Blend command, you draw the shape at one end, you draw the shape at the other, and you can see what happens. It morphs from the one profile to the other. So here's my Blend command. So I can start with a square at one end and then switch to Edit Top. So when you're in the Blend tool, you could switch between top and base, as long as you've got something in it, of course. So you've got two different shapes that you draw, and then over a distance that you specify, so this is 1 foot, I can make it 4, I can build that thing up. So that is a blend. So you can go from squares to circles, you can go from circles to hexagons, you can do whatever you want. The limitation with blends is that the distance between the two profiles is linear and is a single segment. The last little extrusion, or a solid building command here that we'll talk about, is swept blend. So the swept blend is like a sweep and a blend in that you don't have a linear path, you can have any path that you want. So here with the swept blend tool, when you hit sketch path, it's not just a line. So this allows you to have a curved profile on a curved path. So just like we had to do with the sweep, the first thing that you have to do in a swept blend is you have to draw the path first. So when you start the command, you sketch the path. So here I'll just do a simple little curve. Now you folks might guess what has to happen now. I've got this curved path. Now I have to draw two profiles. One for the beginning, one for the end. So like with the sweep, you create the path, you finish it, then I have to select profile 1 and edit it, and then select profile 2 and edit it. So select profile 1, edit. So now you can see at that end, I have to define the shape. So I'm finished at that end, profile 1. Now I select profile 2 and edit that end. So now I can draw the shape I want at the other end. So over that path, it's going to transform from a circle to a hexagon. So I can double click on it again, and then I can go back to the path or the profiles. Now most of what we're going to do tonight are extrudes. In fact, everything that we do tonight will be an extrude. So let's go over to page 3. So work planes, as we have seen, define the starting point for geometry that will then emanate from that work plane. And as that work plane moves around, so if it's, in this case, if it's a reference plane, the geometry that is hosted on it moves with it. Now, actually we've kind of done page 4 and 5 here now, so we can actually move on to main event for tonight, which is creating a window from scratch. Now we are already in the template, so there's not, we'll kind of be moving on to step 1 here straight away. Now let's talk about this whole reference planes business. Now the window that we are drawing tonight is sort of like a Chicago style window where you have a rectangular shape and it's broken into 6 lights. Now one of the principles that we mentioned earlier on tonight was the concept that reference planes are the bones of your family. They're like the skeleton. So we already have reference planes that are provided in the template that are at the edges of the opening So they have already been provided. There is also a reference plane in place already that defines the center line of the window. So that's a center line reference plane, and then there's a left side and a right and a top and a sill. I'll write these in here. These have already been provided. But what we're going to do is we need to create the bones of this window so that these other horizontal divisions can be organized. So we're going to add these two reference planes before we get going too much farther here, because we know that we're going to break this window up into 6 parts. So if you're going to break it up into 8 parts, well, you add that one more reference plane in there to handle that extra division. Let's say that you are doing a door with a side light. And maybe that side light doesn't go all the way down to the floor. The side light is just partial. So in this case, you would already have reference planes for the sides of the door, the bottom of the door, and the top. So what we'd have to do for our side light is add an extra reference plane for that, and probably a reference plane for the bottom of the light at the side of the door. So that is how these reference planes work when we are dividing up a design that we have in mind for a new door or window. All right, so we're going to dive into this now. There'll be a few reference planes that we create in plan as well, and I'll talk about those as we go. Okay, so what we're going to do here is we're going to start in, I think we're going to start in plan. So double click, first of all, make sure you've got all the other geometries deleted, because we're going to use this family in the future. So make sure you've got all that other geometry deleted. So take a second and just clean everything up so there's nothing there except the opening and the wall.
I'm afraid I missed somehow your whole setting up a set of work plane or a reference plane.
Doesn't matter.
Okay.
Yeah, you won't need it.
Good.
Yeah. All right, so let's go then to the plan view. So find under floor plans, find the reference level, and here's where we're going to start. Now, you can see that there is an exterior side and an interior side, and you can see it, there's a double arrow. And folks, whenever you see a wall or a window or a door, this little arrow that you see beside it, this double arrow, will indicate that you can flip it so its orientation is mirrored, and that will always point to the exterior side of the wall, door, or window. So if I go back and look at my project here, there's my wall, and there you can see there's the flipper for it, that little double arrow. Same with this window. When I click on the window, there's the flipper for that. So I can choose which direction that window faces, but these arrows, as a convention in Revit, indicate the exterior side of that object. So now what we're going to do in plan, we showed you the rationale for the reference planes in elevation. We also want to add a few reference planes in plan that are going to handle where our window sits within the thickness of the wall. So on the Create tab, if you folks grab the reference plane tool, and so you can see I'm zoomed in more or less to the opening here where the window is going to be placed. I'm going to add 3 reference planes. One about here. Don't care where I put it, and I'm not going to be disciplined about where I start or end it either. Doesn't matter. There's the first one. Here's the second one. And the last one will be sort of just above that center reference plane, like so. So I've got 3 reference planes that I have just added. Now hit escape a couple times so that you're out of the reference plane command. When you click the outer of those two reference planes, I want you to enable something. When you've got it selected, you'll see in the Properties palette that there's a checkbox for wall closure. Now, you're going to check that, and what that does is it takes the exterior finishes, and when it hits the opening, wraps them around the corner, and then terminates them against this plane. Now, typically what we do is we have our window frame stop at that plane because the frame will meet the exterior finishes. Now, you can do the same on the interior side. So here, click the reference plane that you added closest to the interior side of the wall and hit wall closure. So now my gypsum board will wrap around the opening once it hits the opening and terminate against our window frame. So our window frame is going to span between these two reference planes. Now, this next reference plane here, the third one that we added, is going to be for the glass. So these two reference planes here will define the front and back face of the frame, and then this third plane we added will be for the glass. This other reference plane that you see running down the center of the wall is just for that. It's just to indicate where the center of the wall is, and we don't need it. Now, before we proceed, we're going to give these reference planes names, two of them anyway. So the outermost one, we're going to call that face of window frame. So you can see there I just clicked on the reference plane and gave it a name. Now, the next one inboard there that we created is going to be the face of glass. So when you've got this done now, you're going to have two reference planes that are named. The outermost one is face of window frame. The next one in is face of glass. Now once we've got this sorted, we're going to add some dimensions so that we can control where the window sits within the thickness of the wall. Now, starting from the outside, we will be able to throw on a dimension that controls the setback of the frame from the exterior face of finish. So if we want a window that's deeply recessed into the wall, our dimension will take our whole window and just push it back deeper into the wall. Now we need to add some dimensions to make this happen, but before we go any further, the scale of this view is a little bit too large for the dimensions. So have a look down here at the scale, 1/2 inch to a foot, and I'm going to drop down to 1 inch to a foot, just so that my dimensions will be a little bit more legible when we put them in. So change your scale to 1 foot equals 1 inch. Okay folks, I'm going to grab the dimension command here, and we're going to ask Revit to dimension to wall faces. So grab the dimension command, choose your wall faces option, and here we go. So first of all, we need a dimension from the face of our wall to the outermost reference plane. That's dimension number 1. So find some white space after you've clicked on the wall and then clicked on the reference plane. Find some white space and place it. So this will be the dimension that controls how far back within the wall that the window frame sits. The next dimension will be from the reference plane for the outer frame edge to the one for the glass. Again, move it over to the side, find some white space, and click. The last of the 3 dimensions that we will place is from the inner, or from the outermost reference plane to the innermost one, and you can place that one. So you've got these 3 dimensions. So let's take the one that we just created here. So this is this one that will dimension our frame thickness. Now you'll notice up on the ribbon now there's a label drop down, and if we had a parameter in here already, a length parameter for our frame thickness, we'd be great. We don't have one, so we got to create it. So right beside the drop down is this button right here, which allows us to add a new name for this dimension. So this is going to be frame depth. and hit OK. And now you'll see that the dimension has been given a name. Now, the dimension's a bit ugly, so I'm going to click on it once, then click on it again, and put in 4 inches to clean up the value, like so. Now, pay attention here. You need to find the dimension that goes from the face of the wall to the face of where our window frame is going to sit. Click on that dimension. So it should be the dimension that goes to the face of the wall, and then dimensions to the face of our window frame. We're going to add a parameter for that too. This is going to be window setback from face. And as we will see, the name can be changed anytime you want. So window setback from face. Now that's an ugly number too, so again I'm going to click on it once, then find the text of it where it's turned blue, hit it again, and put in 1 inch. Once that's done, click on our last remaining dimension here. This is going to control how far the glass sits back in the frame from the face of the frame. So click it once, I'm going to add a parameter for it. So this will be glass setback from frame. There we go. And just like we did last time, we're going to clean up this dimension as well. Click it once, click it again, 1 inch. Now, let us suppose you made an upsy-daisy with the name of the dimension. Really important dialog box when you're building your own families is this one right here, family types. Now, I don't really like the name of this dialog box. The reason it's called family types is that it allows you to make new sizes of your windows and doors after you've created the first one. So if I make this original window, it's 3050 say, I can go on and make all the different sizes that I think I'm going to need in the future. You don't have to do that though, because as soon as somebody loads your family into their project, they're free to make whatever sizes they need. So you don't need to make family types for them here and now. People can make their own family types later. So as a result, how many family types do I make with the family types editor? None. I make the first one, I save it, I forget it. The people who use my families are free to make whatever sizes they need. Really, I think of this more as a parameter editor. This is where I can go and rename a parameter if I've messed up the name. So here, glass setback from frame. If I made a mistake somewhere in here with the text, put your cursor in the row and down here hit the little pencil icon, and now I can change its name. Now you also notice that I can change the values here. So if I wanted my frame depth 5 inches, I can put it in here, and you'll see when I hit OK, it's changed the value. So you can change the values of these dimensions here by sort of slow double clicking on them. 1, 2. Or I can go into family types and edit those values here. Whatever. 4 inches. So now what we've done is we've organized ourselves sort of front to back with the window that we're going to build. So now let's build the window. Let's go to the exterior elevation. Now, as I showed on the board, we're going to build a 6-light window. So we're going to add 2 more reference planes here so that we can control where those divisions are made horizontally in the window. So create tab, there's the reference plane command, and I'm just going to add a couple more of these reference planes. They don't need to be named. Now, if we want to, we could add dimensions here so that we could control how far these horizontal reference planes are from the top and bottom. So we'll dimension them anyway. There we go. Now, if you want them to be some sort of useful value, we'll do that. Now, they're not even the same value for each one of them. So I'm going to hit escape a couple times, so I'm out of the dimension command. Anybody remember how you move an object with a dimension? Anybody remember? Cowards. You can't click the dimension, right? If you click the dimension, Revit doesn't know which object you want to move. You got to click the object you want to move, and then you can change the dimension value. So there we go. Now, when you folks add a parameter to a dimension, its value won't change unless somebody, goes into edit type and changes those numbers. These numbers that you see right here, these dimensions, they will not hold their value unless you lock them or unless you add a parameter for them. Now we're not going to add parameters for them, so we're just going to lock their value. So this will ensure that they maintain that 1'6" value in the future. So we are on to page 7. So what we're going to do now is we're going to build the outside window frame. So let's go to the Create tab. So we're about to build our frame. So what we want is we want this extrusion to be starting from that outside window frame reference plane that we created in plan. So here in the exterior elevation, we're going to go and find on the Create tab the Set Work Plane tool. And then once you've done that, you're going to choose out of the menu here the reference plane for the face of your window frame. So the extrusion will start from this plane now. There we go. Now, you hit OK. So now that we've made that happen, we go to the extrusion command. And we're going to draw the edges of the window. Now you can see the background here, we've already got the opening for the window. And so what we want to happen is that our outside edge of the frame is going to stay locked to those 4 edges. So as the window gets wider or taller, the edges of our frame follow to suit. So I'll use the pick tool here. And on the ribbon you'll see lock. So what I'm going to do is going to put my cursor over this one edge here. Now if I were just to click, I'd get this locked at this edge. Instead, I'm going to hit the tab key once, twice, 3 times, and you can see all 4 edges are highlighted. I haven't even left click yet, so this is hover tab click. Grab the pick tool, make sure lock is enabled, hover without left clicking, tab, tab, tab. And now, click. That's what you should get. So now this is defining the outside edge of my window frame. Now, what would be an easy command to get the other set of lines for my inside edge of the window frame? Anybody? Offset, yes. There we go. So we're going to offset by 2 inches. Now, watch on the screen here for how not to do it. Notice the cursor is flashing in the box. Programming geeks would tell you that this box has focus because the cursor is flashing inside of it. What I'll tell you is that hover tab click isn't going to work because my cursor's in here. Observe, hover. Now look at which way I'm hovering. That's towards the opening. This is into the wall. So this is how not to do it. You don't want to offset the frame into the wall. Can't see it. You want to offset the frame into the opening. So now when I hit tab, I want tab to select all 4 of these pink lines and offset them all at once. Can't do it because my bloody cursor is in the bloody box. So see, no worky. So to fix it, click in white space after you've set the value, and now observe, hover to the inside, tab, aha, and now left click, and there we are. So that is our outside window frame created. Now what we need to do is we're going to make dimensions that control the width of our window frame. So go grab the dimension command. And so what we're going to do, watch carefully here. I'm going to dimension from a reference plane. There we go, there's my first click. To a pink line on the inside. So I'm not worried about the pink line at the opening. That's already dealt with. I'm dimensioning from the reference plane to the frame 2 inches away. And I'm going to do that on all 4 sides. Reference plane to sketch line. Reference plane to sketch line, and find some white space and place it all 4 sides. All right. Now, I think I'm going to run out of screen space again here for what we're going to do. So I'm going to change the scale again from 1/2 inch to a foot. And I'm going to drop down to 1 foot equals 1 inch equals a foot. I thought I did that earlier. It's like deja vu all over again. Okay, so we've got these 4 dimensions sitting here. Now hit escape a couple of times to get yourself out of the dimension command. And I want you to hold down the control key and pick those 4 dimensions you've just placed. Now you know what, I'm going to actually skip one. I'm going to shift click it. You don't have to, but I'm just going to show you why. So I'm missing this 1 dimension. You don't have to, but I'm going to show you why I did this in a moment. Now, so you got your dimensions selected. Go make a new parameter for them. This is going to be frame width. And you will see, after you have hit OK, that your dimensions have all been named simultaneously. Now, the reason I skipped this one is because I wanted to show you that if you've got a dimension that you select and you've already created a parameter for it, you don't have to reinvent the wheel. Just go into the menu, go down and find your parameter for it. It'll be in the list, and select it. So there it is. So you can reuse a parameter if it's relevant to the dimension that you're trying to add a label to. All right, so now all 4 edges of the window will have their width driven by this parameter. Now, we need to do the interior bits. I'm going to change the scale again. I think I'm going to run out of room. There. 1.5 inches equals a foot. Now, we're going to use the pick tool again. But instead of just picking, we're going to pick with an offset. So in the offset value here, I'm going to put in 1/2 inch. So I'm using the pick command, and in the pick command, go to the options bar, find the offset value, and put in 1/2 inch and hit enter. Now you have to be careful in this next stage because there's the danger that you could put more than one line down in the same spot. Here's what I mean. I'm going to zoom in on this one location here. So I've got this reference plane that's going horizontally here, and I can see it's picking it 1/2 inch off that reference plane. Now Revit tries to be helpful here. I've already picked that one side, and now it's not wanting to put it in the same place. It's wanting to offset it to the other side of the reference plane, and that's what I want it to do. But sometimes you can have a little cursor jiggle, and then you might end up making that thing offset back to where it already put a line. Try not to let that happen. So you want to offset to one side, then the other. One side, and then the other. And you should end up with something like this. So get to that step. I'll give you about 30 seconds, and then we'll move on. Yeah. Oh yeah, there is. Yeah. All right. Now, the reason that I've gone this route and I've got these sketch lines on either side of the reference plane is we're going to set this up so that when the reference planes move, so shall the sketch lines. Now, we've got a whole bunch of overlapping going on here, so I'm going to show you how you can clean this up in short order. Okay, so you should see all these pink lines on the outside. You've got these pink lines on the inside. So now I'm going to walk you through the process of cleaning this up. Now, on the outside here, our outside edge is fine. That's not the problem. But to make a valid floor sketch or a valid roof sketch in Revit, you can't have any intersections and you can't have any gaps. So here is the quick way to do this as painlessly as possible. You're going to use two commands: split and trim. Split and trim. Now first, we will do the splits. Grab the split command. Now here, this inside line needs to be split right in between because we're going to fillet this line to the outside edge of the frame. So observe. There's the trim, and now here is the, or that was the split rather, here's the trim. Pick the side you want to keep, just like the fillet command in AutoCAD. There. And there. So that's all sorted. I'll go to the next one. Split command first. Split that, and then use the trim command and pick the sides that you want to keep. Okay, so go ahead and do that to the exterior edges. Remember, you're only doing it on the inside edge of the frame, not the outside. Leave the outside alone. Just do it to the inside edge and do it in all, I think it's 8 locations. So there is split, and now here is trim. So the end goal is to have all of those exterior intersections all cleaned up thusly. Okay folks, I'll just get your attention up here for a second just to show you how to do the interior intersections. It's a very similar process, and then you folks can get that done. On the insides, just a single split in the middle of all these 4 lines, and then use trim to clean it up. So here's the split command. Not the one with the break option, not split with gap, just split. So once you got your X-Acto knife, just cut them all in half. And then use the trim tool, pick the side you want to keep. There. And that's all done. So you just have to do it one more time to that other inside corner. Okay, so anybody need a hand with this, just wave and Henry and I will get you sorted. You have, so that's good. We record the dimensions, just go to your exterior elevation. Quick. Yep. And go to your 3. Oh, good. All right, so go to 3. Don't worry about the dimensions. We know that later. So 3. And set. Oh, set. Yep. And pick your upper frame.
You can, yeah, because you can change them.
Okay. So now create extrusion. Here, pick tool. Pick tool, bottom row origin. Okay, nice one. No problem. Lock. Put your cursor over one edge of the and tap 3 times. Perfect. And then offset. Give yourself, yeah, it's already finished. Awesome. So remember, get a tab to the inside. So move your cursor down so you can fix the way you go tab. And perfect. So now you can still have a big tool. Indeed. With a 1/2 inch extension. Absolutely fine. Now, I did get clicking white space recall. And then zoom in on these intersections here. So that'll do. So now you're going to pick that one? Yep. And then that one. That's right. Up and you have to wait. And then right on. Right now, you have yep. And great. Now you see that. Oh, you got that. Just hit escape. And pick that one in the middle and get rid of it. Perfect. Yeah. Now, Yeah.
So where's the first set of dimensions? I didn't get all the dimension sets. Expressing dimensions.
No, they were back in plan, so we talked about them here, and then we mentioned, well, let's just text to us, let's talk. Oh, I see. You might see them, well, I might see them later in the notes. I can see the original video. Okay, yeah, exactly. Sure. Anybody else? You have a question? Okay. Very much so. Exactly. Okay, folks. Just a little thought process here. We have broken up these inner lines here into 3 separate segments. So this used to be a single segment, but now there's 3. So here's what happens. We have a dimension right now that controls this segment. This dimension controls this segment, but not this one. So in the future, if someone were to change the value of frame width, what will often happen is that this segment will respond, and this one will not. So, to ensure that nothing bad happens, here's what we're going to do. We're going to use the align command and force all 3, or these other 2 segments, to move in concert with this one. Oh, and I forgot to put a dimension on this one. Oh no, I didn't. There it is up there. Okay, so here's how it works. So we use the align command for the process, but we're going to use the multiple option. So this means once I've picked my initial reference, anything I pick after that will stay aligned to the first thing I picked. So in this case, this is my first reference because it has a dimension on it. So I click it. Now I pick this segment up here because it doesn't have a dimension on it, and lock it. And that's with the multiple option. And then I can pick this segment down here and lock it. So what this means now is that the top segment and the bottom segment are going to stay locked to the segment that has a dimension on it. So now what I need to do is move to the next location. So I just click in white space, and that changes, it ends the association. So again, it's the first thing you click, that's the point of reference. So I'm not sure which one has the dimension. It doesn't matter, I'll just lock them together. There we go. So once you've aligned those 2, find some white space. Now we'll click the one that has a dimension on it, and then we'll click the ones that don't. So I've got 3 sides sorted. I just need to deal with the 4th side. So click in some white space first. Pick the one that has a dimension on it, then pick the one that doesn't. And we're good to go.
What happens if we pick in different order?
It would actually still work. As long as they're all together, it's all good. Yeah. Good question. Now, we have the frames on the inside, or the frame pieces on the inside, which right now have no dimensions on them whatsoever. So all of these little frame lines on the inside, what would happen to them if we didn't put dimensions on them? What would actually happen is that they would still move with those reference planes. So even though I don't have any explicit dimensional control between these sketch lines here and the other reference planes that are in this family, they will still move together. So there's a certain amount of stickiness between these lines, these pink lines, and the reference planes that you see out there. Now, you probably don't want to trust to that. So what we're going to do is put dimensions on this to show you how you could make it rock solid, and not only rock solid, parametric. So that way we could change the width of these bits of the frame in the future. Now I'm not going to do it all right now. I'm just going to walk you through it, and then you folks can go back on YouTube later and have a look at how it would be done. Now there's two parts to making this work. First of all, I need to do a dimension from one of my pink lines here to its neighbor on the other side of the reference plane. So that's the first step. This dimension right here will be used to control the width of this part of the frame. Now here's the problem. If I were to change the value of that dimension, is it going to move them equidistantly from that center reference plane, or is one just going to move over to the side and one stay where it is? You don't know. And so if you're feeling lucky, you would do nothing. I would advise you to not count on being lucky. So what we'll do is we'll put on another dimension. This dimension will go to those two same locations, but we will also pick the reference plane in the middle. 1, 2, 3, and then find some white space. Now, you guys can see down at the bottom here, there's this EQ option. So what this will force is it will force these two pink lines to be equidistantly spaced with respect to the reference plane in the middle. So I would do the same up here. First of all, a dimension from side to side, and then a dimension with the EQ option turned on. And I would do that just one more time up here, and then we would be done. We will. Yeah, I'm not going to go through that though, because that's something that you folks can do. That's a relatively repetitive task that you could do on your own time. And folks, we're going to go and put in the glass now, but you should come back later and do the alignment. I will do that for you just once as an example, just to show you how it should be done correctly. But at this point, I just want to get to the next steps here so you guys have time to work on the term assignment for tonight. All right, so now that your frame is more or less done, a couple more steps that we have to do before we proceed. Now, first of all, we've talked about subcategories. And as a window component here, in terms of this being a window, this is the frame. Now, if you go and look at the properties palette here, you can see the subcategory is set to none. What does that mean? Revit is putting this geometry into the parent subcategory, windows, which is fine, but really it should be in its own subcategory, frame. So find it in the properties palette, put it into the frame subcategory, and now we'll finish. Now, let's go back to the plan view, and we should be able to see what's going on here. Now you can see straight away what's happened. Our extrusion did indeed start from our window frame reference plane, but it's gone the wrong way. It's extruded out of the window. We'd like it to extrude back the other way towards our reference plane for the back face of the frame. It's an easy fix, folks, real easy. You click on the extrusion, and you can see all of those controls on it. The one we're interested in is this one on the outside. And so you can see it, you can, whoops, click that little triangle, and you can drag it so you can change the thickness of the extrusion. And just like taking a sock and turning it inside out, you can bring that extrusion down past its starting point towards the other side of the wall. but then bring it back and touch it to that reference plane you created for the inside face of the frame. Once you've got there, just release your mouse and you'll see a padlock, so you can lock this thing now, so that its depth will now be controlled by those two reference planes. And just to prove it here, folks, you can see if I click, slow double click on my frame depth here, 1 click, 2 click, and I make it 6 inches, you can see that my frame followed that dimensional value. And don't worry if it doesn't work. We'll do some troubleshooting with you once I've got the stream finished and we've got some time to troubleshoot what you're doing. So the next thing we're going to do is the glass. So I'm going to go back out to the exterior elevation once more. But now this time we're not going to use the frame work plane. We are going to use the glass work plane. So I'm going to go to the Create tab again and over to Set. And this time, instead of the frame, I'm choosing my glass work plane and hitting OK. So what happened with our window frame is that it started on that plane and then extruded towards us. So it started off as being a foot thick and it extrudes towards the viewer. Now what we want to do next time is we're going to do our glass extrusion, but instead of extruding ½ an inch towards us, we want it to extrude ½ an inch away from us. So we will make the extrusion minus 1/2 inch thick, and so that way it will extrude away. So here's the extrusion command. And before we do anything now, we're going to set the end value to -½ an inch so that the glass extrudes away from us. Then the next thing that we're going to do is change the subcategory from frame to glass. So there we go. Now that we're done, we can quite quickly use the pick tool to get all of the bits of glass put in. We've got 6 panes of glass to go in. So here's the pick tool, and lock is going to be enabled. So pick, lock, -½ inch, glass is a subcategory. Hover over one of the inside frame edges. Hit the tab key, I think twice. 1, 2. And it'll highlight all 4 sides. And left click. Go to the next one, same thing. Tab, tab, click. Tab, tab, click, and do all 6 of them. It's kind of a crazy looking bit of geometry, but what Revit is telling you is that the glass is going to follow the edge of the frame. So once our frame moves, the glass is simply going to go along with it. And once you're finished, go have a look at it in 3D, and you should see something like this. So you've got your glass there, you've got your frame there. Everything's good to go. So that's your glass. Now if I want to go back now and make those smaller pieces parametric, I'm going to go back to my exterior elevation now, and I'll just walk you through that process, and then we're going to stop the lecture and kick into some free time for you folks to work on your term project. Okay, so what I'm going to do is I'm going to put my cursor on the frame. Now have a look at what's on the cursor here. When I move my cursor around, it may choose the glass. No, it's not. I'd have to probably tab select to get the glass. Yeah. So when I put my cursor over these different solids in my window, what I want to do is I want to go back and edit my frame sketch so I can see those pink lines again. So what I'm going to do is put my cursor over the frame, click it, and you can see up on the ribbon, edit extrusion. So now I'm back inside the sketch again. Couple things I'm going to do. First of all, I'm going to make a parameter for my interior frame width here. So I'm going to control click those 1-inch dimensions. So I got all 3 of them selected here. And I'm going to add a new parameter for them because I don't have one yet. So I think in the notes it calls it a mutton bar width. I'm just going to call it interior frame width. Interior frame width. You could always go back and change it to mutton bar in family types afterwards. Interior frame width. Now, to make sure that everything works properly here, I'm going to use the align command. I'm just going to do it once. You guys will know what to do on your own later. So I'm going to use the align command, which is this one right here, align. So first of all, I'm going to deal with the center spine, and then you guys will know what to do. So first of all, I've got the multiple options selected. I put my cursor over this edge. What am I clicking? The glass. That's not even what we're talking about here, folks. I want to grab this sketch line, but it's going to the glass. So what I have to do now, tab. Hover, one click of the tab key. Now what is Revit saying? Sketch line. Good. So now I can click it. Go to the next line up here. It is getting the sketch line. If it said glass, don't click it. You need to grab the sketch line. And now lock it. Up to the top one, is it glass? Come on, cursor, tell me. There it is. Nope, it's a sketch line. That's cool, I can click it too. And lock it. So now, because I've got the multiple option going here, I need to reset my point of reference, so I need to find some white space. I go to the other side, find the sketch line with the dimension on it. It's not picking the sketch line, so I have to hit the tab key just once. There we go. And now I can click it, and that's my point of reference. I can pick the next sketch line here, unlock it, and the next one, and lock it. So I'd want to normally make sure I'd done them all before I finish, but just for the sake of time, I'll finish it now. So now, once you're done, you'll have control now over all of these interior bits so that you can control their width independently of the frame on the outside. So if you make an upsy-daisy again with the name of the parameters, don't forget you can go into family types, find the parameter you want. So this one here, if I want to call it mutton bar width, I just put my cursor in there, hit the pencil icon, mutton bar width. And so now it's been renamed. Hit OK, and OK. Right, folks, so that is the end of the lecture for tonight. Maybe I'll just spend a couple moments here just talking about flexing. This is good practice to do after you've made your own family. You want to use the family types dialog box and just see what happens when you put in some different values for the family. If I make it a little bit bigger, if I make it a little bit smaller. So here I can go into family types and I can try making my width 2 feet. Is it going to give me any problems? No, looks okay. Now folks, look at these two values here, 1'6" and 1'6". What happens if I make my window 3 feet high? What happens to these panes of glass? If I make the window 3 foot high, what happens to these ones? They become what height? 0. Can Revit make a 0 height extrusion? No. It's like the sound of one hand clapping. It's not going to work. So if I go in here and I put height in of 3, constraints are not satisfied. This is the kind of nonsensical English that Revit will tell you when something screws up in your family. Now there's usually a logical reason for it. And basically you can see here there's 14 errors, all hell is breaking loose. Why? Well, we know why. Because we're creating a 0 height extrusion and it can't be done. So, you know, if I do something like 3'4", should be okay. Yeah, right? I still got a little bit of room in between. But there's a lot of different kinds of errors that families can give you, and it's for reasons like this. You're doing something that would essentially break the family. Now, if you see those errors, you can always cancel out when you're in the Family Types dialog box and have a look and try and understand why Revit is giving you grief for the changes that you've just made. But Family Types will allow you to try some different dimensional values for your family, and you can just be satisfied that everything's moving and that nothing's come out of alignment, and that you can proceed with your family. Now, we do a lot more of this in the advanced course, so we'll leave it at that for tonight. And if you're interested in that stuff, you can take on the 2805 class next term.